Hi students, this is Mr. Yao. Today we're going to talk about 6.4, where we will learn about proofs in coordinate system. Let's first review some concepts about coordinate systems. Number one, linear equation. That is y equals mx plus b. Next, slope formula. Some of you might think y equals mx plus b is a slope formula. Actually, that is the equation. When we actually say slope formula, we're just trying to find this letter m right here. So slope formula is m equals y2 minus y1 over x2 minus x1. Next, if two lines are parallel, that means their slopes are the same. We can also use the other way. If their slopes are the same, then they are parallel. And if two lines are perpendicular, their slopes are opposite reciprocal. If you forgot what that means, opposite is talking about the positive and negative. Reciprocal is actually about the fraction. So for example, 5, the reciprocal would be, opposite reciprocal would be negative 1 over 5. It says negative 1/2. The opposite would be positive. Reciprocal would be a 2. Or it says like say 2 over 3. The opposite reciprocal would be negative. Flip the fraction, 3 over 2. These are the concepts we're going to use. Let's practice a little bit with these concepts we have learned. Example 1, slope. x1, y1, x2, y2. So negative 1 minus 1 over 5 minus 3. That is going to be negative 2 over 2, which is negative 1. Parallel, the same, so negative 1. Perpendicular is the opposite, so it's got to be a positive. And 1 is just 1 over 1. So flip is the same thing. Perpendicular is 1. Example 2, 1 minus negative 2 over 5 minus negative 3. That's 3 over 8. So parallel, 3 over 8. Perpendicular, negative 8 thirds. Example 3, slope, negative 1 minus 1 over negative 5 minus 2. That is negative 2 over negative 7, so it's 2 over 7. Parallel, same. Perpendicular means opposite, so negative. Reciprocal, 7 over 2. These are review. Let's move into actually doing coordinate system proofs. And we have midpoint and distance formula that we have learned. Just have a look at it real quick again. Add the coordinates together, then average, that's the midpoint. And distance, we could use Pythagorean theorem. So that's basically the rise, that's the run, and we just make the triangle. Now, example 4. So let's first draw the shape. W is negative 2, 5, right here. X is 2, 5, right here. Y is 4, 0, right here. Z is 0, 0, right there. There's our parallelogram. And the question says they intersect at A. So I'm going to connect the diagonals. This point they intersect, that is going to be our A. And it's asking us to actually find the coordinate for A. So if you remember, the diagonals, something special is they bisect each other. And if you actually just want to use slope and distance slope, you can. However, that's not the fastest way or the more direct way. So that's why let's think more. Diagonals, they bisect each other. Another word to say for bisect means midpoint. We say this line is bisecting the other one. That basically means the point that they meet is the midpoint. So A actually is the midpoint of WY or XZ. So in order to find A, I'm actually just finding the midpoint of WY or XZ. And I can say A is midpoint. So now I just need to find the midpoint. For WY is going to be, I forgot to put my Y is 4, 0, and that is 0, 0. So WY, negative 2 plus 4 over 2, or 5 plus 0 over 2. that is going to be 1 and 2.5. If you actually want to use xz, that's going to give you the same thing. So that is example 4. Next, example 5. D. D is at 0, 2. E is at -1, 5. G is at 4, 0. And I'm going to connect them. Okay. Then you're going to see, wait, I need to find this F. Where is this F? Well, it's in order E, F, G. So F is going to be like on the right side of E, G. So I'm going to tentatively put one somewhere so I can actually have a parallelogram I can look at. Again, of course, you can use distance, you can use your slope, you can try to solve equations to find where F is. And I know you can eyeball this one, but we're actually learning how to properly find where the point is. So we're actually going to use something that we have used. I'm going to connect my E and G. That is the diagonal. And I'm also going to connect my D and F. Let's call this midpoint A again. Okay. We can totally find the midpoint. And if you recall, for D, A, F, they're on the same line, and A is the midpoint of that as well. So that means if I can actually find A, I already know D. That becomes something we have done in 6.1, example 5 and 6. We know one point, we know the midpoint, we're trying to find the third point. So let's start with finding A. A is going to be the midpoint of EG. -1 plus 4 over 2, 5 plus 0 over 2. That is going to be 1.5 and 2.5. Next, I'm going to use my D. My D is 0, 2. So basically that means I know my 1 point, I know my midpoint. I'm going to say F is xy. That means I can actually represent my midpoint, which is D in this case, with the A. I can represent my A with the D and the F. So my D is 0 for x plus x over 2. And then it's 2 plus y over 2. And that is my point A, represented by D and F. So clearly you already know the coordinates, so this has to be equal to 1.5. That has to equal to 2.5. And after solving, x is 3 and y is 3 as well. So my F is going to be 3, 3. And that is the proper way of finding about example 5. Now let's move on. This time it's asking you to show that is a parallelogram based on what it's asking you to use. Definition of parallelogram, that means we're trying to do double parallel. In order to prove lines are parallel in coordinate system, we're actually going to use slopes. So let's actually graph the points real quick first. 0, 1 is right here, A, 4, 4 is right here, B, 12, 4 is around here, C, 8, 1, 12, 4 is actually around here, C, and 8, 1 is right here. I'm going to connect them. And again, if you're trying to prove they're parallel, you need to find the slope. So the slope of AB is, I'm going to use the points AB, so that's 4 minus 1 over 4 minus 0, so that's going to be 3/4. The slope of BC is 4 minus 4 over 12 minus 4, which is 0. Of course, the slope of CD is 1 minus 4 over 8 minus 12. That is -3 over -4, which is 3/4. Lastly, m of dA is 1 minus 1, and 8 minus 0 is going to be 0. Now you can see, I can conclude these two are the same. So that means AB is parallel with CD. These two are the same. I can conclude BC is parallel with DA. So that means I can conclude it is a parallelogram by definition. That is example 6. Next, example 7. Start with a point, -2, 3, J, -2, 3, K, -5, 7, that's K, L, 3, 6, and then 6, 2, M. So connect them. Okay. This time it's asking to use converse of one pair of opposite sides, both parallel and congruent. Parallel is easier to use. I'm going to use, you can either use KLJM or KJLM, either one. I'm going to use KL, and I'm going to use JM. I can find their slope. KL, 6 minus 7, 3 minus -5. That is going to be -1 over 8, so it's going to be -1. JM, that is going to be 2 minus 3, 6 minus -2, so it's -1/8 as well. I can prove KL is parallel with JM. Now I also need to prove they are congruent. In order to prove they are congruent, I need to show that their distance are actually the same. So the distance of KL, that's going to be 3 minus -5 then squared, 6 minus 7 then squared, which is going to be 8 squared plus 1 squared, so square root of 65. And of course, I can use the same thing, Jm, that is going to be 6 minus -2 squared, 2 minus 3 squared. That is also going to be square root of 65. They are the same. I can conclude KL, the measurement of that is the same as the measurement of JM. So now I can so it is a parallelogram. That is example 7. Next, we're actually going to do some more about special parallelograms: rhombus, rectangle, and square. And these are the features we can use to prove. Let's have a look. First, example 8. Put the points out, -4, 2, okay, 0, 3, okay, 1, -1, L, 3, -3, -2, M. Connect, connect, connect. You can kind of see that is going to be a square. So for square, I have 2 different ways to prove. One, I can show all sides congruent, and I can also show all 90 degrees, or perpendicular, either way. So perpendicular just means we're finding the opposite reciprocal. So that means you need to find all the slopes. Slopes for JK, slope for KL, slope for LM, and slope for MJ. I need to find each one of these. Slope of JK, that would actually be 1 over 4. Slope of KL, that would be -4. And the slope of LM, that would be -3. Well, actually, -1 over -4, so that's 1/4. Lastly, MJ, you can see that is going to be -4. And you're going to need to pair each one of them up. So these two together, I can show JK is perpendicular to KL. These two together, I can show KL is perpendicular with LM. These two together, I can show LM is perpendicular with MJ. And of course, these two together, I can show mj is perpendicular to jk. Now I need to find all the length. So d of jk, that is going to be, that is 4 over n1 square root of 17, and d of kl, square root of 17, lm, square root of 17, and mj, square root of 17. All the same, so I can show. That's the first method of doing this problem. There's also another way. I can show diagonals, bisect, and perpendicular. That's another way. Because that's something very special just about squares. So I can do that as well. I'm going to say this is the midpoint. Let's say it's O. So first I need to show the midpoint of JL. And that is going to be -4 plus 1 over 2, 2 minus 1 over 2, which is -1.5 and 0.5. Next, I can show midpoint of KM, which is 0 minus 3 over 2, then 3 minus 2 over 2. I still got -1.5, 0.5, and they are the same. Which means that is going to be O. They share the same midpoint, which means they actually bisect each other. And of course, I still need to show that about JL and MK. The slope of JL is going to be -3/5. And the slope of MK is going to be 5 over 3. Clearly, you can see they're perpendicular. So that's a second way to prove it is a square. Forget to write is actually a square. That's example 8. Example 9. 5, 2 is J. 2, 5 is K. -1, 2 is L. And 2, -1 is M. This one clearly is a square again. And since it's going to be the same process, I'm actually going to move on to talk about the next one. So, something I want to emphasize. If you want to show something is a rhombus, you need to show all sides congruent, but you also need to show no perpendicular. Because a square, that's the more specific one, then you need to show they are actually perpendicular. If you want to say it's just a rhombus, you also need to show they are not perpendicular. So this actually is very important. And if you're trying to show it's a rectangle, you can show perpendicular that you have all 90 degrees, but you also need to show not congruent. The sides are not congruent because if they are congruent, then it's going to be a square. That's one way to do it. Another way to show rectangle is you can show diagonal are actually congruent, not perpendicular. Because if they are actually perpendicular to diagonals, that would also make it a special case, a square. So you need to make sure you show that. And to go back, another way to actually show it's a rhombus, you can show diagonal are actually perpendicular, but not congruent. These are the important things that you actually need to show to make sure what you're trying to find is not a square. Now let's move on to example 10. Example 10. We're trying to prove triangles are congruent. You have several ways to prove. One, you can actually use side, 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 which means you can find AB, which in this case is 5, and you can find the corresponding one, which is FG, that is also 5, so that's one side. Then you can find AC, which in this case is 3. The corresponding side is FH, which is also 3. You can say yes. Last one, you also need to find BC. That actually, after solving, is going to be square root of 34. Then you can find it's the same for GH. After solving, that is also going to be 34. So they're all the same. You can use SSS. And the second way, here's a second way you can show they are congruent, is you can kind of see they're perpendicular. So you can show that MAB is 0 and MAC undefined. Well, I actually had it backwards. MAC is 0, MAB is undefined. That means AB is perpendicular with AC. Same thing for the other one. FG is 0 and FH is undefined. That means GH is perpendicular with GF. So that means you actually have some 90 degrees. And if we have 90-degree angles, they're all right triangles, I can start using HL. So you can use the two sides, H and L. Then you can still show they are congruent. That is example 10. Next, example 11. This time we're showing two triangles are similar. So first, let's find them. A is -2, 0. B is 0, 4. C is 2, 0. Okay, I'm going to connect them. Then I have PQR. My P is -1, 1. Right there. And 0, 3 is my Q. And R is 1, 1. So here's my little triangle right there. In order to show they're similar, we can't exactly use angles. So the best way is actually to use SSS, which means I need to find all the ratios. In order to find the ratios, I need to know how long they are. So the measurement of AB, measurement of BC, measurement of CA, measurement of PQ, measurement of QR, and measurement of RT. Let's find each one of these. For AB, that is going to be 2, the other one is 4, so it's going to be square root of 20, which is 2 square root of 5. BC, that's going to be the same thing, 2 square root of 5. CA, that is actually a flat line, which is, okay. Next, if I want to find PQ, that is 1 and 2 in the right triangle, so it's square root of 5. QR is also square root of 5, and RP, when you look at it, is just 2. Now I need to actually compare all the ratios. So AB over PQ, that is going to be 2 square root of 5 over 5, so 2. And next, BC over QR is also 2. CA over RP, that is also 2. Which means they are all the same. So by side, side, side similarity, I can conclude triangle ABC is similar to triangle PQR. That is example 11. Last one, example 12. I have a couple things I need to show. First, Draw the shape. -4, 6. That's A. -6, 2. -6, -2. That's B. 4, -2. That is C. I can actually find their midpoint first. So D is the midpoint of AB, which means -4 plus -6 over 2. 6 plus -2 over 2 is going to be -5. E is the midpoint of BC, I mean AC, so it's going to be -4 plus 4 over 2, and 6 plus -2 over 2 is going to be 0, 2. So the midpoint, -5, 2, right here, 0, 2, which is right here. That's my D, that's my E. Next, you're trying to prove D, E are actually parallel. Whenever we want to prove parallel, we're going to use the slope. So for part B, I need to find the slope of DE, which clearly is 0. The slope of BC is also 0, and that means they're the same. I actually wrote them wrong. So the slope of DE, same as the slope of BC. So parallel. Last thing, part C. Now I need to show that it's half. So now I need to find the distance of DE, which in this case I can just count, which is 5. Distance of BC, I can also just count, which is 10. So I can clearly see DE is half of BC. That is example 12. That is everything for 6.4. Thank you.